Hey there! We're going to talk a little bit about Chapter 1 and the map skills that we're reviewing for all of the geography classes that you're going to be taking in the future. In your Chapter 1 of your textbook, Section 3 is going to cover title, compass rose, key, some of the basic features on a map. Section 4, we're going to talk about the global grid, the latitude and longitude lines that you see that help you find absolute location. Section 5, we're going to deal with distance and learn how to use that scale that's on the bottom of most maps. And Section 6, we're going to talk about how we divide the Earth up into chunks, hemispheres, continents, and oceans. Sections 7 and 8 in your textbook are what I would consider an extra challenge. You're going to be talking about this later on in 8th grade Earth Science. But this is the Earth and Sun relationship and map projections. And again, this information will be covered briefly in our unit, but it won't be a major focus. I'll tell you what you exactly need to know. So in Chapter 1, Section 3, we're talking about the title, compass, and key, those features on the map that will help you find your way around. The first clue about a map's content is the title. So while it's something that you know is there, make sure you look at it because it's going to give you an idea of what exactly is on that map. This will come into play more importantly when we talk about thematic maps in Chapter 2, when 5 maps are going to cover the same physical boundaries, but each map is going to represent something different. Your cardinal directions are going to be found on your compass, and these main cardinal directions are north, south, east, and west. You'll see a compass rose that often looks like this, but sometimes a compass rose could simply be an arrow facing north with an N. You'll also have intermediate directions, and these are the directions in between northeast, southeast, southwest, northwest. Whoops. And so you may have all 8 cardinal and intermediate directions on a compass rose, but that's not necessary. A key is also referred to as a legend, and on the key the symbols should relate to the topic that they are representing. For example, an airport should look like an airport with an airplane or a symbol that references an airplane. Cities are often shown with a dot. A regional capital like a state capital or a province capital is usually shown with a star, whereas the national capital is shown with a star and a circle. Those are common symbols you'll see on a key. Cities are often written with a capital letter and lowercase. Regions are often written with all caps, and a larger reference like a country name is usually written in bold and all caps, and sometimes it's even underlined so that you can tell the difference in the size of those features. When you're looking at a key, I also always recommend that you check for colors as well as symbols, because sometimes there's multiple layers of information that they're providing on a single map. And then don't forget that the scale for a map is usually close by, and we'll talk about that here in just a second. Chapter 1, Section 4 is dealing with the global grid, latitude and longitude. And some of the differences between latitude and longitude. Latitude are parallels, means they never intersect. And some of the major lines of latitude that you need to know are 0 degrees is the equator, 23.5 you have those north of the equator and south of the equator. Those are your tropics. And 66.5 north and south are considered the Arctics. Arctic in the north, Antarctic in the south. The parallels of latitude are going to measure north and south of the equator. So you'll always have a number in degrees followed by one of these 2 letters when you're referring to latitude. Some helpful memory tricks perhaps to differentiate between longitude, as I like to consider flatitude. They would lie flat on the ground if we stacked them all up. Or they are the rungs of a ladder and they count up and down from the equator. On the other hand, meridians of longitude are not parallel, which is why we refer to them as meridians. The main line that you need to know is the prime meridian at 0 degrees, and then its opposite on the other side of the globe is the international date line, which is at 180 degrees. These lines are going to intersect at both the north and south pole, and then you're going to measure east and west of the prime meridian. So you'll see a number measured in degrees followed by either east or west. We like to think of long hair. If this was someone's long hair going up and down, that might be a memory trick that helps you differentiate longitude lines. When used together, these are called coordinate pairs, and they're going to mark the absolute location of any feature on the globe. For example, Barstow is located at 38.9182 degrees north and 94.6048 degrees west. We can shorten that down to 38 degrees north and 94 degrees west. You always put latitude first. You'll do some practice with coordinates in math class when you start to graph, and your x-axis will always come before your y-axis. So you're going to see a lot of similarities between math and geography. Math and maps. There you go. Another interesting tidbit of information is that the distance between 1 degree of latitude is approximately 69.2 miles, or approximately 70 miles. So if you were going from 0 degrees at the equator to 38 degrees north, you're traveling approximately 70 miles times 38 degrees. And you could find that distance with that math equation. Section 5 is going to deal with distance and scale, and what I really loved in the book was the phrase that it's going to shrink vast distances of space, and it's going to make them easier to understand and basically easier to see on a map. We can't see the entire distance of the country of Brazil, but if we shrink it, we can see it on a map and we can better understand the size when we see it compared. Usually written in inches on paper, to comparing that to the miles on Earth, or if you're like every other country in the world, kilometers on Earth. So oftentimes on the scale you'll see both references to miles and kilometers. When you use scale, do not use your fingers as a reference. This is very inaccurate. And so if I try to hold my fingers here and then move them to a map and try and use the scale that way, my fingers are going to move. It's just going to happen. So don't use that as a reference. Instead, you're going to grab a piece of paper or a note card, and you're going to mark on your paper exactly where the 5 is so that you can use that reference on your map and find the exact scale. You'll be more accurate that way. Now, don't worry about references in the book to large scale versus small scale maps, because I think the way they use those phrases seems a little confusing or counterintuitive. The next section is on hemispheres, continents, and oceans, and I know that you've been learning those for a while now, so just wanted to remind you how we come about with creating those hemispheres. We divide the Earth in half, and hemi means half. And the prime meridian, remember, divides the Earth into the western hemisphere and the eastern hemisphere, while the equator divides the Earth into the northern hemisphere and the southern hemisphere. So you're not actually going to have a northwest hemisphere. You'll have a northwest quadrant. So the United States, our country, is located in both the northern hemisphere and the western hemisphere, but not the northwest hemisphere. So it's a little minor language issue. And we divide the world up into 7 large land masses, a couple of which are combined together, but we have 7 continents. And in order from largest land area to smallest land area, we have Asia, Africa, North America, South America, Europe, Antarctica, and Australia. And we have 4 oceans, the Atlantic, which is often referred to as the North Atlantic or the South Atlantic, but still one ocean, the Atlantic. The Pacific, the Arctic, the Indian Ocean, or according to the International Hydrographic Organization, there's also a 5th ocean, and they're still defining where they want the boundaries of that ocean to be, but you will hear some references nowadays to the Southern Ocean, which is an important ocean because it surrounds Antarctica, generally from about 60 degrees south to the South Poles, the reference to the Southern Ocean. And because of climate change and rising sea levels, that's a particular part of the ocean that scientists are very interested in nowadays. So you will hear reference to that. But National Geographic does not refer to the Southern Ocean as one of the major oceans of the world. Section 7 and Section 8, these are those advanced challenge sections that I referred to. And while we're not going to be covering this information in sharp detail, there are some key things that I would like you to remember. In the Earth and Sun relationship, there's a couple of terms. You'll hear revolution and rotation, and so try not to get them confused because they both involve spinning, but it's a different kind of spinning. When I revolve around the sun and get back to my original spot, it's going to take me 365 and 1/4 days or a year. But when I rotate around my axis, I'm going to take 24 hours to get from night to day and back again. You're also going to see a diagram in your textbook that has a lot more information on it in specifics about the details, which again is an additional challenge. But the most important thing that I need you to picture in your mind is that there is a tilt to the Earth. From the magnetic North Pole to the South Pole, there's a 23.5-degree tilt. And that number should be reminding you, oh yeah, that was those tropic lines that Ms. Pavard mentioned. So at 23.5 degrees north, we have the Tropic of Cancer, and at 23.5 degrees south, we have the Tropic of Capricorn. And again, at 66.5 and 66.5 south, we've got the Arctic Circle and the Antarctic Circle. And so what these lines are in reference to is the sun's direct rays shining at different times of the year because of the tilt. You'll get more direct sun at the equator in the summer, which will then create more sun in the southern hemisphere. And so when it's summer in the southern hemisphere, the northern hemisphere is getting less direct rays from the sun, and that's when we have our winter. So your seasons are flipped in the northern hemisphere and the southern hemisphere. When it's summer in the north, it's winter in the south. So Brazil in July is going to be cooler than Kansas in July, and vice versa. And then our rotation is going to create a day in the western hemisphere when the sun is shining on it, and night in the eastern hemisphere when the sun is not shining. You'll also hear some terms, solstice and equinox, which refer to specific days of the year when the sun is shining at different points on the globe. Section 8 has to do with map projections, and again you'll see diagrams and charts that relate to different styles of map projections. I'm not going to make you memorize Mercator, Robinson, Goods, Eckert, Lambert, and all of those, but what I do want you to think about is that every map is going to have distortion in one of three ways. The size of things. Remember Greenland when it was as big as the entire North American continent? It might distort the shape of things if something's really stretched out and looks skinny, or really stretched out and looks wide. Or it might distort the distance, and it might show that something is much farther apart than it actually is. Remember Bob and his hair. The main idea I want you to get out of the distortion section is that when you see straight longitude lines on a map, you're going to have a lot more distortion in the north and south poles. When you see a map with more curved lines, you're going to have less distortion. So especially in our first unit when we talk about Canada in the northern hemisphere or Russia in the northern hemisphere, you're going to see a lot more curved lines because we're reaching the North Pole where those lines of longitude are all going to come together.